Okay, so this is question 17. Tan squared x minus sine squared x is equal to sine squared x tan multiplied by tan squared x. Okay, so first 17b asks what are the basic identities needed to solve. So because we have a tan x and we have a sine squared x, I'm going to use the Pythagorean identity. So I put sine squared x is equal to 1 minus cos squared x. And then the tan x identity is tan x is equal to sine x over cos x, which is also could be used as tan squared x is equal to sine squared x over cos squared x. Same thing as in like cos squared x can equal 1 minus sine squared x, or 1 is equal to full chaos, or 1 is equal to cos squared x plus sine squared x. Okay, so then question C asks to simplify the left side. Okay, yeah. So the left side is tan squared x minus sine squared x, tan squared x minus sine squared x. So we're going to change the tan into the sine version to make it easier, because this part is also, so the minus sine squared x is in the sine. So we want to also make the tan squared x, whenever possible, into that sine squared x over cos squared x. So then we do, minus sine squared x. Then to subtract, we need common denominator. So we multiply the top and bottom by the cos squared x. And then we get basically sine squared x, subtract by sine squared x multiplied by cos squared x over cos squared x. So then we want it to look like the right side, which is sine squared x, tan squared x, sine squared x. So we want it to look like the right side, which is sine squared x, multiplied by tan squared x, right? So if we look at it right now, it's like this. Basically what we have is sine squared x minus sine squared x, cos squared x, cos squared x. But we want a tan, right? So in tan, if you think about it, the sines at the top and the cos at the bottom. So we have a cos at the bottom, yay. But we don't have all sines at the top. So I'm thinking maybe we should change this into, with the Pythagorean identity, 1 minus sine squared x. See where it leads us. Then, based on that logic, that's what I did. Then I changed it, but I'm still not getting sine squared x, tan squared x. So probably because this is still in its bracket. So I suggest that we FOIL. So when we FOIL, we get negative sine squared x. So sine squared x minus negative sine squared x. Then it's going to be minus, so negative sine squared x multiplied by negative sine squared x gives you two negatives, give you a positive. And because we're multiplying also the exponents, when you multiply, you add them together, so you get 4x. And then because it's sine squared x minus sine squared x, we cross that out because they're basically equal to 0. So now we have sine to the power of 4x and cos to the power of 2x. We still don't have our, we want our tan squared x. So some people can just look at it and think, hey, if you think about it, if that sine divided by the cos, you get a tan. And then you're left over with the sine. So what I'm trying to say is, look. So if I just put it as sine squared x over cos squared x, and basically broke it down where it multiplied by sine squared x, because the two do give you sine to the power of 4x over cos to the power of x, because it's over 1, right? So I broke it down, and then I'm thinking, hey, this goes back to tan squared x and sine squared x. So here, left side is equal to right side, because we want sine squared x, tan squared x, which is what we get. But sometimes you might be just like stuck on this part. You're like, sine to the power of 4x and cos to the power of 2x, and you don't think, hey, maybe I can break it down, or maybe this is sine over cos, so this can automatically become tan, and then we're left over with a sine squared x, like this. So this can become straight away. Some people straight away think, hey, this can become this, and this can become this. But if you don't think like that, you can just go to the right side. When you go to the right side, it's sine squared x, tan squared x. So we'll just change that tan straight away. So it's sine squared x over cos squared x, which gives us sine to the power of 4x and cos to the power of 2x. So you can just say, hey, left side equals equal to right side. But make sure when you end the left side, you end it like that. So instead of going all the way to down here, you would end it off like here. And then you would go onto your right side, and then you would say, this is your right side is also equal to, therefore left side is equal to right side. So question D is asking if it's necessary to use right side. It's not necessary to simplify, because if we were to, because when I did it, I broke it down and I ended up getting the answer straight away. The beginning sine squared x, tan squared x, I got at the end. So sine squared x, tan squared x, basically the same thing, just move it around, but it's basically the same thing. And then, yeah, so you know it's not necessary, but sometimes we don't pick up on those, like, hey, clues, like, hey, you break this down. This is basically sine squared x over multiplying by sine squared x, because those two exponents can give you sine to the power of 4 over cos, and this becomes a tan, and this just stays by the multiplying it by sine squared x. Sometimes we don't pick up on that, so sometimes you can use the right side, but it's not necessary to use it. And then question E is asking if both sides are not equal, it's just telling you do it over again, but we don't need to because we get left side equals right side. So I just said two sides are equal. That's it.